So the last thing that I want to show you from a troubleshooting standpoint, we looked at sort of top down, bottom up, is how to take a look at your RF environment. So let's say through this process, we detect or suspect rather that we might have something in the RF environment that is maybe we've got some co-channel interference, something that's interfering, or maybe we've got multiple clients that have opened tickets in the same geographic area or associated with the same access point. For whatever reason, we want to look and make sure that our RF environment is good. So what we do is we'd come down here to wireless and go to RF spectrum. And what I'm going to do is I'm just going to look for um, I'm going to look for our worst performing access point in this network. So this page, what we've got is we've got a dedicated radio on all of our access points that's just all the time looking at the RF environment, looking at for things like channel utilization and packet loss and interference and things like that. Um, and all that's displayed here. So what we can do is we can toggle for channel utilization, and all that means is so this access point is on channel 6 right here. This is access point number 3. It's on channel 6. Um, and so that means that, roughly 65% of channel 6 on the 2.4 gig band is full. Kind of a rule of thumb, anytime you get north of 50% channel utilization, you're going to start to get packet loss. And we are seeing some packet loss. Right. It's not as bad on the 5 gigahertz band. Um, this isn't that bad, but it's still, one of the higher ones or near one of the higher ones. So let's take a look at this access point. If I click on here and then toggle back to 2.4, because that's where we're seeing the um, higher saturation of that channel. This is going to show me where potential interference sources are. But you can kind of see here that we don't have any interfering APs. We don't even have any overlapping, APs. But that's because I've got this in-network toggled on. So we do a pretty good job of controlling our RF environment. But quite often, you're in a situation where you don't there's, let's say you're at a clinic in a strip mall or something like that. There's a lot of different uh, stores or shops or other places around you with access points. That interference could be coming from APs you don't control. So if I toggle this off, there is all our interference. We have 69 different interfering radios. If I hover over here, yeah, pretty high interference. So that's where that's coming from. And I can scroll down here and I can see exactly what those sources are. Now, I, you know, I know just because I know the environment that this access point is on the fourth floor, which is where our the product team for all of our wireless stuff is. This is where they test a lot of our wireless gear. So I know that this this environment's got a lot of interference sources on purpose. That's what they're doing. So that's what's going on there. But let's say you find yourself in this sort of situation. Like what can you do about that? What can you do about this sort of interference? Well, there's really only two things that you can do. You can change the channel, and you can adjust the transmit power. So in the past, you would have to come in and manually change the transmit power and the channel to try and make sure you're moving stuff around so there wasn't interference. Then we came out with a feature called Auto RF that would do that dynamically. Um, and then we've just not too long ago released something called AI RRM, which is what we're using here in this network. It's the evolution of Auto RF. And so it dynamically, it'll look in your environment, see where there's interference, dynamically change the channel and the transmit power, but it's going to do it intelligently using AI. So it sucks in like 2 weeks worth of data. It looks at your environment. Um, it looks at the, number of clients there, traffic patterns, things like that, and models all that, and then makes changes more predictively. And so you can see, our RF performance is really good. RF coverage is fantastic. You can click here on more details, and that's going to show you over the last 14 days, RF score, um, a low point of 96 perhaps, the different channel changes that it's made, where you've got high co-channel interference. Um, uh, so the results are really, really good. Um, I do actually want to pop over and show you a slide. So we've had AIRM on for a while, but when you first turn it on, um, it's going to wait, like I said, it's going to wait 14 days, it's going to wait 2 weeks, and gather that data, and then it's going to make those changes, you know. And uh, the feedback that we've got, the improvements that customers are seeing when enabling this is pretty impressive, even over auto RF. Um, and so let's take a look here at our poor performing access point. Yeah. So even our poorest performing access point still has via AIRM, a pretty good RF score. But maybe we want to do even a little bit more to mitigate them. We could, all the interferences on that 2.4 band, we could come over here to the RF profile, and either shut off the 2.4 band completely by deselecting this, or we can enable like band steering. And so what that would do would move any client capable of going on the 5 gigahertz band off 2.4 and onto 5. So there's just fewer clients to be impacted, less congestion on that 2.4. So those would be options as well. Okay, so that's it on troubleshooting. There's certainly more we could go over, but that's probably sufficient. I do want to shift and show you just a couple ways to get a little proactive, a couple ways to optimize, maybe get out in front of those tickets. One of them would be um, this little diagnostics option we've got. So if you come to wireless and then access points, right up here at the top, you'll see just some recommendations based on other customers uh, with similar networks. So if I click run diagnostics, I could, we're Cisco professional services, but I could say healthcare, very large environment, and it's going to give me some feedback based on what we're seeing at, or just best practices at similar verticals and similar size customers. So um, you click on this. One tip would be, hey, decreasing the number of SSIDs to 3 or less is going to reduce latency. It's going to show me the APs with the most SSIDs. That would be one. Maybe we've got a few too many SSIDs. Let's come down here. We have a higher than average channel utilization on 2.4. So moving clients to the 5 gigahertz band reduces latency by up to 100%. Okay, so that could be significant. And then recommendations, hey, enable band steering. We were almost there. So that's just always something, interesting just from a best practices standpoint to look at. It's important to set up alerts. So we have some pretty powerful alerts just built into the dashboard. So if I come down here to wireless, went up to network wide, alerts, wireless, just out of the box, we can get alerted either via email or text. If a gateway, which is an access point, goes offline for 5 minutes, if clients have poor signal strength on any SSID, a specific SSID, if clients are failing to connect, we've got similar alerts on switching and things like that. So this is all email, and you can see there an example of text. But I could come down here We could alert via API calls. We could alert via webhooks. Um, and so, if you wanted to get your alerts via Microsoft Teams or ServiceNow, Zendesk, Jira, whatever platform you use for ticketing, they could we could use webhooks to feed those alerts directly into those platforms. Um, and then the last thing that we didn't cover is more application monitoring. So we went through a lot about clients, wireless, network troubleshooting. But if you wanted to really see in depth on specific applications, specific URLs, and things like that, then we'd use Thousand Eyes. Thousand Eyes can be built into the dashboard here. But I'm going to let Adam show you how that would look.